Hey grade 12s, welcome to my channel, and let us have a look at this question paper as a review and some form of revision on some issues you probably need to be aware of before your next exams. Now I'm using this KZN paper because of this copy being available to me. Otherwise, could have done any paper from any other province. So if you have a special paper or a particular paper from another province, or even a particular question that you may need my opinion in it, so you know how to contact me, just check on the information of my channel. You will see my email address as well as my WhatsApp number, so you choose whichever suits your needs. Otherwise, we are going to review this paper and try to share some insights into how to handle these questions. And of course, guys, from, for any paper, we need to be particular about the instructions contained. We need to read all. Some are very, common, but instructions like this, as well as this instruction, they need to be internalized. Not to say others are not important, but these ones have a particular interest for a student because this is where the marks get scored fully if these instructions are adhered to in the solutions. Of course, we need to be aware that the diagrams are not necessarily drawn to scale, so we need to not read too much from the diagram, but the diagram still has to transmit the correct information, which will be proven by the calculations. But this is where most provinces fail when it comes to designing, correct diagrams, if I was to put it that way, or representative, maybe let me put it that way, representative diagrams. There is a failure from the quality assurers or whoever, moderates the process. It means someone is failing and this needs to stop, okay? Anyway, you may have noticed, guys, I kind of disappeared for a while. Unfortunately, our family had been bereaved, so we had to take care of that. But now that this is over, I am back, so we're just gonna work again. So those of you who have been attending my classes, I am back, guys. We're going to start again on Monday, 7 o'clock at night, and we'll just work as usual, hoping that by the time you sit for your next exam, everything will be, on point. Now, let's have a look at this question 1. We are given the sum to n terms of an arithmetic sequence is given by this general formula. Now, in my opinion, once we see a general formula having the highest power being in the order of 2, this means it's quadratic, okay? And if it is quadratic, it means this is an arithmetic series. Now this for me is too much information. This is more like turning an exam into some form of a classwork. To me, for this to be a proper exam, we should not specify the sequence because this is already suggestive. There can never be a sum in general that is quadratic, which is not arithmetic, okay? We have seen that. So these are some of the things I feel sometimes we make it too easy. Although we still need to keep pushing. Anyway, guys, let's just keep going. I don't know who's trying to call me, but yeah, they're disturbing me. Okay, so anyway, let's just get to the situation and just keep going. So 1.1, we have 1.1.1. The question says we need to calculate the sum of the first 21 terms of this sequence. So we know that Sn is given by 3n squared minus 5n. This implies that S sub 21 should be 3 into 21 squared minus 5 into 21. Therefore, the sum of the first 21 terms is, let's get to the calculator, otherwise, wow, 3 into 21 squared minus 5 into 21, so this gives us 1218. Okay, that's easy, not a complicated question. So what matters is just to make sure the substitutions are correct and the operations on the calculator are correct. Otherwise, there's no way of proving this otherwise, okay? Unless you really want to waste a lot of time, with other methods which could prove very long. Determine the 22nd term of the sequence. Obviously, guys, from the lessons I have provided you at the beginning of the year, obviously, this should be very easy. We should know that T22 is going to be S22 minus S21, right? Why? Because when we add the first 21 terms and the first 22 terms, when we take the difference, what will remain is the term number 22. So that's what's extra there. So logically, it makes sense. So this implies that T sub 22 is going to be equal to 3 into 22 squared minus 5 into 22. Now, subtracting this is just that one we did above. So some questions are quite convenient, but be very careful that this answer is correct, because to plug it here again may be very dangerous. So therefore, term 22 is going to be 3 into 22 squared minus 5 into 22 minus 1218. So I'm getting 124. Okay, so attending classes is very important, because some homework, classwork, whatever you call, can actually show up in the exam. Okay, this is the easiest it comes. At times, this becomes an indirect situation, and it can prove very challenging. Now, this whole shenanigan right here is a different calculation, so we get a mark for that, and the final answer. Okay, good. So 1.1.3 says how many terms of this sequence must be added to obtain this sum. So this simply says S sub n should be 8162. Now this implies that, perhaps let's shift it a bit. So this implies that 3n squared minus 5n must be equal to 8162. Now we can see a nice quadratic. 3n squared minus 5n minus 8162 should give us 0. Now we cannot divide by 3 here, technically, so we just attempt to factorize. Now, all we need to consider is this coefficient. So there's what we call the PAF method, or PAF, which is product, addition, and factor situation. But anyway, guys, you don't need to know too much as long as you understand what to do. So what is important is this last one. We just press it on the calculator as I am writing. And then once we do that, we hit the shift button, and then we hit the fact button. It literally breaks this into its prime factors. So let's do it. 8162 shift fact. So I'm getting 2 times 7 times 11 times 58. Okay, so obviously 58 is already a big number, so it makes sense to try and combine these. Okay, so if we combine these, what do we get? So we have 2 times 7 times 11. Remember, sometimes it's trial and error, so you're not so sure what you're dealing with. 154 times 58. Now, we know that one of these factors has to multiply that factor, which is a 3. Now it would make sense to multiply the 3 to the smaller one, right? So that we can see what we end up with. So what we have now is going to be, of course, 154. Let's see. So we have 53 times 3 gives us 159. And indeed, 159 minus 154 is definitely going to be 5. So we've got our factors. So this is going to be 3n. This one is small now, so it should be plus 154. And then we're going to have n minus 53. So that we set this up. So guys, you need to be comfortable with this. But of course, if not, there's no harm. Just go for the quadratic formula. So therefore, we know that n is equal to minus 154 over 3. Even if this is a whole number, this cannot be the answer because n is an element of natural numbers, which is positive integers starting from 1. So that's the story. Or n is going to be 53. So we need to answer the question. Therefore, 53 terms of the sequence need to be added to obtain 8162. Okay, we can prove this by substituting 53 onto the left hand side here and see if we are getting the same answer. So what we can do here, we just come back here, provided this is correct, we just plug 53 there. So let's see, 3 into 53 squared minus 5 into 53, what do we get? 8162. So this means our calculation is proper. So when we have an equation of some sort that's having some left hand side and some defined one side, our job is just to prove that the one side is equal to the other side. And so we can move on with the knowledge that we did this well. So obviously, guys, substitutions important. Part of the 3-step approach, factorization is important, and essentially answering the question. So that's 3 marks, but now we're scoring 4. So I don't know where the 4th mark is, but I would perhaps say writing this in standard form is a mark. Okay. Yep. So yeah, this is one of those things. This is one of those things. Anyway, the 4 marks have been scored. So let's move on. Okay, let's get to the next page and do 1.2. Now 1.2 has, we are told to consider this sequence. So 7, 7, 7, 12, 7, 17, 7, 22. So it looks like if we can ignore the first 2 sevens, because if this were given 3 times in a way for each repeating, or should we say for each of the terms that seem different, it means this continuation is of this one. And technically this is a mixed sequence. Okay, but another student may decide to exclude the 7 and start from the 12. That's still okay, because this is already showing that there is that mixed sequence. Now, if we start off and say, okay, remember the start is anything technically. This can be anything. The numbers don't necessarily have to be sevens. They can be 5 and 2, whatever the examiner decides, but luckily it somewhat fits into the identity of the repeating sequence in there. Why? Because we can see that essentially we've got 7, 7, 7, where we have also 12, 17, 22. So we can clearly see that the odd positioned terms form the repeating sequence of sevens. All right, and we look at the blue ones, the even positioned terms. So 12 to 17, that's 5 more. 17 to 22, that's 5 more. So basically we have a repeating sequence of sevens plus an arithmetic progression, okay, with A equals 12 and D equals 5. Okay, we need to be able, guys, to see these things before somebody tells us, okay, because many of you guys are not so strategic. So this is not a question you just answer. Okay, you have to plan how you answer it. All right, now we are asked a question to determine the value of the 78th term of this sequence, and it's just 2 marks, but this is not a walk in the park. Now let's see, how many terms do we have? 1, 2, 3, 4, 5, 6, 7, 8. So this means we need 70 more terms, literally. We need 70 more terms. Now, this is going to be after 22 and going forward until the 78th term. It will be a total of 70 terms. Right. Now, we know that those 70 terms are going to be of the signature of the boxed sequence, which is the mixed sequence. So there's 2 sequences there. So this implies we're going to say 70 divided by 2, because if we look at it, 70 is an even number. It can divide 2, because look at this, how many terms are here? 1, 2, 3, 4, 5, 6, and out of 6 we divide by 2. Guess what? We get 3 of each. So we're gonna have 1, 2, 3 of the odd, and then we've got 1, 2, 3 of the even positioned terms. So this gives us 35 of each sequence, in the mixed version. Okay, so basically we're going to have 35 terms of each sequence in the mixed version. Okay, that one doesn't look so right. Okay, that's much better. Now folks, remember this very term 78 is an even position. So this means this is going to belong in the even positioned sequence. So we know that, okay, okay. Our job now is to find, now remember, we know that therefore the sequence to look at that answers the question is going to be 12, 17, 22, all the way. Now remember, this is going to be 35 plus, we're going to have 35 plus the first 3 terms, 1, 2, 3. So we're going to say here 38 terms. Okay, do you see what I just did? First, I wanted to know how many extra terms do I need? 70. Now 70 is an even number, so that means this will be evenly distributed to the even positioned sequence, which is arithmetic, and the odd position sequence, which is a repeating sequence. But now I realized again 78 is an even position. So this clearly tells me that the one sequence that will answer this question is the even positioned sequence, which is the arithmetic progression. And that's what I'm choosing right here. But now this progression already had 3 terms already in place, which is that 12, 17, and 22. Now I need to add the 35 terms that are going to be there, because that term number 38 is essentially what answers my question. Because if I find term number 38 of this even position sequence, when I consider all these others now, it will give me that term that I'm looking for. So again, guys, there's many ways of killing a cat, but how you look at it, you're gonna just, go on and deal with this. So we know that the AP, the 35 terms, we're going to have to add the first 3 terms to obtain 38 terms. That means the last term here should be that 78th term. Good. So we go on and say, well, 78 is going to be equal to T38 of the arithmetic progression in the mixed sequence. Okay. At the end of the day, this one is too complex to be exact. Okay. So we cannot really, maybe you may want to be more elaborate and say starting from the 3rd term of entire sequence. Because the times of the entire, maybe let's shift you a bit, of the entire sequence. Okay. So in any case, you may say this, I suggest you do if you can, because there's nothing that beats being exact in conversation, because you are trying to own your approach, so that even if there was a doubt, you copied, or maybe some students were caught cheating, you don't become one of those students who get victimized. Because remember, being elaborate, you may find it unnecessary, but there will be a situation where students in a particular school, someone or maybe some of them are caught cheating. And now when you look at the answers of this student, you will pretty much understand the framework, because especially if this shows up in your rough work and you then take this to here, this kind of gives a clear indication that the student was doing this by themselves. Anyway, guys, I'm just showing you tricks so that you can be good at what you do. So we have now T78 equals, this is going to be A plus N minus 1 times D. We need to show the formula. So T78 is going to be A, which is 12, plus N, we said it's going to be term number 38 minus 1. The common difference there is 5. Okay, here you don't need to be separating things too much. You can just go in. Everyone understands what's cooking. Okay, great. Now we can say from here, therefore, T78 is, let's see, this is 12 plus 38 minus 1 into 5, getting 197. Of course, guys, this one without proper planning, you are dead. Okay, so this is a higher order question, and you may expect questions of this nature in the NBT examinations as well, because it's typical of the two. Usually in the NBT you get higher grade type questions, not necessarily too hard, but at times it's a matter of knowing how to figure things out and then how to fit them together nicely, then work the problems. Okay, let's have a look. How many marks should we be scoring here? Obviously, folks, this calculation on its own is a mark. Okay, great. And this entire situation is yet another mark. Can you see just the 2 marks are coming from a situation you wouldn't believe, is going to be done that way. So maybe let's write here 1.2. Say this is 1.2.1. Okay, please label the questions or the sub questions correctly. Again, this is another issue that can lead to marks being lost. Now we need to calculate the sum of the first 103 terms of the sequence. Again, another issue. 103, it's an odd number. Now, from this 103, what happens when we exclude these terms? Now let's say we are going to exclude these terms. So I'm going to say here 103 minus 2 terms. It leaves us with 101. Again, still an odd number. Okay, now if this is an odd number, we know that there will be one extra odd term or odd positioned term, which means the repeating sequence. Now we will just ignore the 1 and just say, okay, let's look at the 100 terms plus 1. Okay, now the 100 terms, we say 100 divided by 2, because this is an even number. That means the 2 sequences are going to evenly distribute, so that we have 50 terms of each. Now, of the 50 terms of each of the sequences, we know that the odd position sequence is going to carry an extra term. So we say 50 of each at first. We say then this implies that there's going to be 50 of the AP and 51 of the repeating sequence, isn't it? Because we know that here we split this 100 to 100 plus 101. Then these ones will divide evenly for the 2 sequences in the mix. Then this is an odd position, 101. There's going to be 1 extra. Hence we have a situation of 50 for the AP, and we have a situation where we've got 51 of the repeating sequence. But now remember, we need to look back again. This number has a striking resemblance to this sequence, because these are all 7s. So this means here we're going to add those 2, which is going to be now 53 of the repeating sequence. Technically, we're going to add 53 terms of the repeating sequence to 50 terms of the arithmetic progression. Now that would be the sum of the entire 103 terms. So guys, again, thinking about splitting things in a strategic way, but again, recorrecting yourself, you end up where you need to go. So we can say S sub, maybe let's start here, Sn. I'm trying to think now, how am I going to do this? I want to write the formula, then substitute. So let's write Sn here is going to be equal to n over 2 for the arithmetic part right, plus, now these ones are 53, so this is going to be n into 7, but again 7 could be considered the first term, so we can say essentially NA, A being the first term of whatever sequence. I mean, it doesn't really matter. The repeating sequence is basically the first term repeating itself. So I think that would be best to write it like that. So this implies that S sub 103 is, we said 50 of the arithmetic progression. So this is 50 over 2 into 2 into 12 plus 50 minus 1. We saw that D was 5. That's it. Plus N here is 53 of these numbers, 7s. So therefore S sub 103 is going to be what we get. So let's see, what do we get? Technically, I have got 50 divided by 2 into 2 into 12 plus 50 minus 1 into 5. Okay. Then here we're going to add plus 53 into 7. So I'm getting 70, 96. Okay. Now again, guys, here what matters now is to know for sure that the planning is good. Again, you can show the planning on the rough work so that this doesn't look too far-fetched. But again, you know what? Maths is maths, guys. Sometimes, as long as you have some legal means of doing it, and everything, if one was to plug this on the calculator, gets this, and that's the correct answer, then who cares? Nobody cares, okay? As long as we are clear what formulas we used and what we are doing. Okay, so first of all, this is a calculation on its own. Nice. This is also a calculation on its own. And then the general substitutions and the final answer. So that's how we score those 4 marks. Nice and easy. Okay, these are some of the questions that look scary, but sometimes you just realize that no, man, there is nothing here, but yes, there is something in there. I think it's careless to think there is nothing. Hope you guys understand the plan, the attack. Eventually, we've done it. Okay, let's move on to the next question. Start on the new page. Question 2. Question 2, we are given sigma of this number starting from 2 ending up at 13. But now any base to some particular exponent represents for us that this is a geometric series. And this geometric series is such that the first term is going to be the 2 being put there. This is a square, so this becomes 9. The common ratio becomes the base of the power there. Okay, so usually this is the case, but be very careful. Sometimes this is not k minus 1 to suggest, some typical general term for a geometric progression. So this may turn up to be arithmetic. Be very careful. Sometimes when you're not sure, just skim and scan the questions here. Look, write down the values of this, write down the value of the constant ratio. That's a clue that says, indeed, you're not making a mistake. So remember, sometimes you're not sure of what you're doing, but you have a clue because you have been studying things and noticing these patterns. So at times you just want to confirm, am I right? Now there's no way I can be asked about a constant ratio if there is no constant ratio, and therefore it cannot be anything but that. All right, okay. And then, can you see, will this, converge? Again, if we talk about convergence, it's a geometric series. So indeed, we are where we need to go. So we can easily just start answering the questions now. So we've got 2.1 with 2.1.1. Now it says write down the values of the first 3 terms of the series. So that's easy. Just going to use the sigma of minus 3 to the exponent k. Maybe let's just say is equal to, put a 2 in there, it's a square, so minus 3 squared is 9. Plus, is it going to be a plus? Well, a sigma means plus. So essentially, this is going to be 3. Now the negative remains. We can decide to write here minus 27 if we like, then plus, just to protect our pluses, to try to be particular about our sigma. But we know this is going to dissolve into a minus. And then the third term, so when we put a 4 in there, so this becomes 81. Okay, and then this keeps on going. At this point, we were not asked the last term, but the first 3 terms. So that's it. We get our 2 marks nicely. No questions about it. So 2.1.2. Question says we need to write down the value of the constant ratio. So if it says write down, we just do it. But you can see here minus 27 divided by 9 is minus 3. 81 divided by minus 27 is minus 3. So whether we read it from the formula or we write it down, it doesn't matter. 1 mark. So we have 2.1.3. This says, will this situation converge? Obviously, guys, the common ratio is less than minus 1, so it cannot. So we can say no. The value, we know that r is less than minus 1. Okay, that's it. So this is a divergent series. You can say even here, therefore, this is a divergent series, geometric series. Okay, that's it. So this is a divergent geometric series. So we get a mark for our answer and our reason, and perhaps the conclusion may be important, may not be important, but the fact of the matter is that we're getting our 2 marks. The other way is to notice that r must be less than or equal to minus 1, greater than, is it equal to? So called r must be less than 1, greater than minus 1 for convergence. Now you can see that r is outside that range, so you can even use that explanation to get things around. But again, I mean, take the simpler route and not complicate your life. But there's nothing wrong in complicating your life, okay? Now we're told here to evaluate, or I mean calculate the sum here. But now we have a situation here that says we've got sigma k starting at 2, ending at 13 of minus 3 to the exponent k. This is going to be 9, times x. Okay, there's an x now. This is going to be equal to 9x, okay, plus, in fact, do we need to put a plus? It's going to be minus 27x plus 81x plus dash dash. The last one is that 13. Well, do we need it? I don't think so. Now we need to calculate the sum here. So we know that Sn is equal to a into 1 minus r to the exponent n. Why am I choosing this formula? Because my r is less than 1. So this is the best formula. Okay, so this implies that s, now how do we find n? We say the top minus the bottom plus 1. So this is going to be 13 minus 2, which is 11, plus 1, it gives us 12, equals a here is 9x into 1 minus into minus 3 to the exponent 12, all divided by 1 minus into minus 3. So therefore s sub 12 is what we will get. So we start here, we say just 9 into 1 minus into minus 3 to the 12, all divided by 4 literally. So what do we get? We get minus 1,195,740x. Okay, again here, the trick, guys, is to ensure that the substitutions are correct and the operation is correct. How many marks here? 3. Or for the number of terms. Okay, that's good. So this is nice and easy, not too complicated. Okay, let's look at the next question in its own page. Now again, you are hit with a higher order question, which is more likely to be a question again in the NBTs, if any one of you is going to be writing those. Now let's have a look. We are told this is a quadratic sequence. Now this is very important, because when information is given like this, it helps to know what sequence we are dealing with. With a general term that has the following properties. Okay, all right, okay. Now I asked a situation that says determine the value of the first term of the quadratic sequence. Now notice something. This is Tn minus Tn minus 1. That means the term I had minus the term before gives us this. But now what is this, guys? This is the general formula of the first differences. This is the general term for the first differences. Okay, so obviously this is going to be starting from T2 minus, the situation, because we cannot have term 1 here, right? Because if you put term 1 minus term 0, then we don't have a term. Okay, because if we say 1 minus 1 is 0, so term 1 is literally going to give us, a ridiculous situation. Okay, so this one is crazy. This one is crazy. So technically, guys, this thing is suggesting that for us to win here, we need to say T2 minus T1, because this is going to be T2, 2 minus 1 is 1. But now this is going to be the second term of the arithmetic sequence, not the first term. So this can be quite a nightmare. But now I have a few strategies that I have in mind. Let's say we've got the quadratic sequence, which is term 1, term 2, term 3, and then it goes on. Okay, and then we're told here this is term 29. Okay, at least this is where we stop, and then of course it still continues, right? Now we know that if we say term 2 here, n is 2, this is going to give us the second term, right? And that's the problem, because now you can tell that T2 minus T2 minus 1 is going to be 3 into 2 minus 4. Now as you can see, this is going to be term 2 minus term 1 is equal to essentially the second term, and that's not true. This cannot be equal to T2, because we know that term 2 minus T1 is going to be T1 of the arithmetic sequence. So this formula is bad. These are some of the reasons you ask yourself, do the people who design these questions ever think about what they're doing? Is it even correct to do this? But again, guys, the notation is a mere suggestion of what is expected. But for me, this worries me, because it's not telling the truth. Because as you can see here, this is suggesting term 2. Remember, term 2, this is going to be T1 of the arithmetic progression made by the first differences. this becomes term 2. But now we don't get term 2 when we subtract term 2 and minus term 1. So can you see this whole thing is imperfect? And this is not supposed to be represented. This is imperfect. And anything imperfect, guys, needs to be not even given, because it leads to problems. All right? So again, guys, those who are tasked with the job of, ensuring that this quality of papers is, ensured, the quality assurers, the subject advisors in schools, and whoever is really in the position of ensuring that things are going okay, they need to think about the things they write down, because the things you write down need to be representative of what we are dealing with. Otherwise, we end up with wrong answers, because now, as you can see, the imperfection here is going to create a nightmare. This is going to create a nightmare. Although the general formula to the left is somewhat convincing, this thing is convincing, but now it doesn't tie with that thing. The problem is that there's no tie there. Things are not gelling. So now, guys, what do we do? What are we supposed to do? Now we're in trouble, because obviously if this is a quadratic sequence, we know that we need term 1 here as the situation. So now, guys, we will have a situation where term 1 is literally going to be 3 into 1 minus 4, which is going to be equal to minus 1. Then the term 2 is going to be 3 into 2 minus 4, which is going to be equal to, this is 6 minus 4, which is 2. So now we can do this using these two if we like, because obviously we can see the common difference here is going to be 3. This is what we need to think about. So we can either work out term 1, because this represents any term technically, by the mere fact that this is the story. But the problem is that this is wrong, in that it does not give a true definition of a quadratic sequence. And because of that, we have a problem. You get it? We have a problem. So this means this cannot be used. Otherwise, it's bad. And again, think about this question from March 2018. Please go look this question paper up. I have done this at some point in my channel, if I don't remember, or if I remember well, I think it's there. Do have a look in there. In fact, I'm starting to think now, was my answer correct, or were my answers correct? But I still believe I did it in 2 ways, if I'm not mistaken, and the answers kind of tied up. But if they don't, then we have a problem, guys. As you can see, this general term should not be given. It's a no-no. Anything that is imperfect, guys, should not be included. It's very dangerous. It's dangerous information. Anyway, guys, so we can clearly see that from the general term, 3 must be the second difference in any case. Then we can just work out the first term and then work things out nicely. So for me, I'm going to use that and then use that term that I'm given to make life easy for me. Now let's start answering. So we've got 2.2 before we lose too much time. So we know that the quadratic sequence is going to be term 1, term 2, and then term 3, and then it goes on until we have term 29, which is equal to 1166, and then we've got another terms after that. Okay, So we know that, well, the difference between the first two terms is going to be essentially 3 into 1 minus 4, which should be equal to minus 1. And then the difference between these two is the second term here, using that formula as it is given, so we get 2. And of course, this forms a sequence. It's ongoing. But if this is quadratic, we don't need to prove that this is a common constant or is a common second difference. We know that if this is a quadratic, there will be, the second difference is going to be constant. So you can just show this construct and then we'll work it out. We can start. We will say here, well, we know that essentially 2a is equal to 3. Therefore, a is basically 3 over 2. Nice and easy. We can say here also, we know that essentially 3a plus b. Now I'm going to do it as a substitution. Remember, the very first term is going to be 3 into a, which is 3 over 2, plus b should be the first term. So I'm going to show it like this so that you can see the first term is represented by 3a plus b. Then this implies, okay, I don't need to say anything. We can just move quick. So this is going to be minus 1 minus that value. So minus 1 minus 3 into 3 over 2. So this gives us minus 11 over 2. Okay? And then, what is the story now? We can say here, however, we were told that T29 is equal to 1166. Right? What does this imply? It implies that essentially a into 29 squared, knowing that Tn in general is an squared plus bn plus c. That's what I'm doing now. So we then sort it out. What is a? A is 3 over 2 into 29 squared plus, now this is going to be, okay, we can just do it like so, plus minus 11 over 2 into 29 plus c is 1166. I don't like the drifting. I like it when things tie up nicely. But again, in the exam, there's no need to do what I'm doing, okay? But try when you can. Think about it, that you must be able to draw a straight line across the equal signs. This makes the work easy to follow. It's nothing special after all. So from here, guys, we can see that this helps us to solve for C. So this is essentially 1166 minus 3 over 2 into 29 squared, right? Then minus into minus 11 over 2, into 29, right. So what am I getting? 64. Okay, so what are we looking for? The first term. Now here, guys, I mean, it's 6 marks, so is it necessary to do the first term? I mean, come on, we can just say therefore T1 is going to be equal to A plus B plus C. Okay, maybe let's just try to be in the conversation. Too many conclusions don't make sense. Then we know T1 is going to be A plus B plus C, right? Because we don't need the ones. But we can put 1 squared, but B into 1 plus C. Honestly speaking, I don't see the point. Okay, maybe we should not. I don't care. Now, this implies that T1 is equal to A is 3 over 2 minus 11 over 2 plus 64. Therefore, T1 is equal to, let's see, we have 3 over 2 minus 11 over 2 plus 64. So this tells us that term 1 is 60. Okay, nice and easy. So we have done it, guys. Nice and easy. Now, yeah, let's check. This is now a check, not a part of the answer. Just want to make sure that everything ties up. We saw that Tn comes up as 3 over 2n squared minus 11 over 2n plus 64. Right? Right. Now, I want to prove that everything ties up nicely. That this is the general term for the first differences. We want to make sure that it is so. We need to see some consistency. Second, we need to prove that the quadratic formula is essentially representative of all the terms. First of all, let's check the terms here. T1 is going to be obviously 60 because that's what it's going to give us. So we know that T1 is 60. T2, let's check what T2 is. So we've got 3 over 2 into 2 squared minus 11 over 2 into 2 plus 64. So the next term is 59. Okay, actually, why do I want to write like this? Let's just say the quadratic sequence here is going to be 60, and then the next one is 59. Let's check the third and the fourth. So let's see the third. Remember, guys, everything you do must tie up. I'm getting 61. I just want the fourth because I want to see everything gelling. Everything has to gel. And then the last term, of course, non-contiguous to these ones. If everything works out, surely it should be right. So this is 66. Then, of course, let's check 29, term number 29. Is it as was given to us? Yes, it's 1166. All right, and then let's check, is the sequence of the first differences going to tie up? What is 59 minus 60? Yes. It's essentially minus 1. And then what is 61 minus 59? Oh, it's a 2. What is this one? What is that one? 66 minus 61 is 5. What is this one? It's 3. What is this one? It's 3. Can you see? This ties up nicely. Because if we were to look for the general term for these, it fits that one perfectly. So it means our calculations are super duper good. So guys, it helps to be very, very careful of what notations to use. Now, please do not use this calculation here. And B, do not use Tn minus Tn minus 1 equals to 3n minus 4 in your calculation in this manner, where we write Tn is just the nth term, right? Now the nth term, we don't know it like this, right? Because we did not first get the term. So don't use something like an squared minus b plus bn plus c minus, say, a into n minus 1 squared plus b into n minus 1 plus c is equal to 3n minus 4. Do not use this. This is forbidden. You will see when you use this, you're not going to get the same answers. It's going to be incorrect. Why? Because it moves our sequence by the first term, the one of the first differences. It pushes us to starting from here. And if we're starting from here, we are not going to get the answers that we are looking for, okay? Because this whole thing just keeps on going wrong. It just keeps on going wrong because it's just making no sense. So don't do this. And I think there was a question where I did this, but I'm not too sure. Everything tied up there. I'm trying to think now what could have been. I don't remember, and honestly, how I did it, but I did it using this technique, so to speak. And it worked either way. So essentially, don't use this technique though. It's wrong, okay? Do not use it. It's wrong. And the first term of the first differences is not 2. Okay? So be very careful, because using this, it forces us into that situation. If we use this formula here, then we end up starting there. And that's not correct because it doesn't represent a quadratic sequence fully. So be very careful of the techniques you use in answering questions. Some sound right and convincing, but they are actually wrong. Okay? They are actually wrong. So I don't like problems. Problems are not right. Okay, so anyway, guys, let's leave you here in the interest of time because it's easy to lose it. So this is a check, folks. Please, it must not appear in the exam. So I can see nicely that the formula I got is fully representative of the sequence, especially this term that was given to me. And it also fully represents this sequence of the first differences exactly as that general formula, because this will come out if I solve for it, right? Because I can do it. Tn is going to be a, which is minus 1 plus n minus 1 into 3. So this is going to be minus 1 plus 3n minus 3. That is 3n minus 4. Can you see? Everything, guys, is tying up nicely. So we know that our check is good. Okay? So be very careful. Sometimes you will see strange things, but I'm interested in knowing what the memo has. Actually, this question paper has a memo at the bottom. But hey, anginasikhathi akinanako nalo ixesha lobe ndijongana nee-memos zizandipopanisa ndisebenzise yam ingqondo neyam ingqiqo ukwenzela uba ndiyibone uba into enobuchopho bam iyasebenza na. Now ndifuna nazi isiXhosa ke ngokukazi, ngoba ndiyanazi isiXhosa nisazi, thathi ndinifundise nje language kancinci. EsiXhoseni xa sithi ingqondo, ingqondo means inside. Okay? It has nothing to do with the brain. Not brain. Okay? Insight is some state of mind, isn't it? So this is the state of mind. Mind is not the brain, right? It's everything around the brain, its functionality and stuff. Of course, if your state of mind is poor, the insight becomes clouded, isn't it? Yes. But now, let's take ngobuchopho. Ubuchopho. Ubuchopho ke mandibhale kahle. Kanti utheni no-H wami efuna undihlanyisa? Ubuchopho. This now means the brain. The brain tissue itself. So there's a difference. So ingqondo is carelessly used for this. Who doesn't have a brain? I mean, is it possible to say umuntu ophilayo akanangqondo, as in akana brain? There's no sense in that, right? Yes, even though it sounds right, it's ridiculous. Please don't go around saying crazy things here. Xhosa nisazi futhi mina. Funa unixelela namhlanje. Mna-ke ndiyincutshe yesiXhosa. Ndiyinjengalwazi. Andinayo kodwa i-PhD yesiXhosa kodwa ndiyinjengalwazi. Andidingi maphepha azondixelela into yoba ndiyayazi into endiyithethayo. Tyhini maphepha okwenzani? Ewe, kodwa ke khona ezinye izinto ongenawuzenza ungenampepha ngoba zichaza into yoba kunganengozi xa ngabe wonke umntu angavela agxophuleke phaa, ngoba wonke umntu ukholele ekubeni unolwazi abe engenalo. Wonke umntu ucingela uba unengqondo abe engenayo. Now, so uyayazi ingqondo yintoni? Insight. That is a deep understanding. That's a state of mind of perfection. Yayiva ke ngoku le nto. Otherwise, okay, all right. Abe ndinipha nje igrama nje yesiXhosa guys, uba nikhe nisifunde naso. Ningahambe nithethe into engekho apha. Akanangqondo lo mntwana. Awunangqondo. Ingqondo yakho ayisebenzi kanjani? Awukayivaphi ingqondo engasebenzi? Ikhona, andikhumbuli. Yes, sis man. Thetha udodi. Ngobe nibe proud. But damn it. Nizangihlanyisa. Anyway. Anyhow. Remember this 3, we may have read it from the general formula. The coefficient of n is the constant second difference, yes. So this one we know that this one is going to give us a mark. Right. But there's a lot of work that we did here. We first worked out the first term, but then the substitution, doesn't really matter. So this is the third mark. Okay, all right, okay. Technically, all of these flipping substitutions, yeah, when 10 ngathi uzosixaka nje. Sesinanga 1, 2, 3, 4, 5. And then ke yiyolya. Zi-6 as our marks. And ziyamecha. Yo. Ungazodlala. Anyway, guys, let's move on before I lose my crap and stuff. Excuse me for the language, guys. Sometimes, it feels good to say nonsensical things, but it can be offensive to, some super sensitive, fragile individuals. We know they exist in the world, those people. They exist, so we need to think about them, I must not be selfish, you see. Yeah. So now, guys, EC trial 2022. A question like this came out. Showed you guys how it's worked. So anyone who truly uses my channel maximally, I promise you guys, you wouldn't escape a distinction, provided you're not just in the movies when you're looking at my channel. You look, you try, you then perfect, because you will do what you see me do. First of all, you can just watch the video from the beginning to the end. Then after that, you can actually reproduce what you see. by redoing that paper. Download it and do it again. You will see you will get stuck. Trust me, you will. Even though you've seen how I've done it, you will get stuck. This is when you start to get a reality check that what you think you know is not true until you put it to the test. Then after that, you take other questions and see if now your awareness, remember, don't skip procedures I show you. Do them as unnecessary as they look. Do them. That fortifies your quickness in the brain to then skip unnecessary things while preserving the right things. But you don't start doing that if you don't even know what is unnecessary and what is necessary. That's why you do the whole thing. Okay. Now the question says show. Now a show, guys, remember this is 2 marks. But you can't just write this answer, because we know an answer only is a mark. But a show, hell no. A hell no. So sometimes you need to marry the action statements and the mark allocation. Sometimes the mark allocation can be misleading, or even those statements can be misleading. Now when there's a mismatch between the mark allocation and essentially the action statements for the question, it means the quality assurance is poor. Because why would you have a question like this written in the exams or in the question paper and then you pass it? Because there's no match. Now you're going to confuse students. Remember, we teach them standards. If this particular word says, if you're doing a show, guys, you should be expecting to do 3 marks minimum and more, depending on the complexity of the question. But now you guys, but now guys, I use long division, the first technique. From long division, I can write here from long division. You can do what I'm doing, guys. Now remember, guys, what are we doing? We want to divide this by this. Ne? We want to divide this by that. But in my opinion, this is not ready for long division. Maybe let's hold it on. Remember, we normally don't like, denominators that are negative. So let's just first sort this out. We know that f of x is literally 2x plus 3 over. We factor out the negative. I think this is important. We can say therefore f of x is, we move this to the top. Now that's better. Over x plus 3. Yes, this is good. Now, what are we trying to do, guys? We are trying very hard to then, this is our dividend. Maybe I need to just break it up as well. The way it looks, I don't like. Maybe let's not do it like so. Let's just remove the brackets. So the negative is going to affect everything, Yeah, it's like this. Now, folks, we want the dividend. Remember, the numerator is the dividend, right? The denominator is the divisor. That's what we divide by. Okay, now we want the quotient, because we know the product of the quotient and the divisor plus any remainder is going to give us the dividend. Now from long division, we know that x plus 3. Of course, guys, you could still do it the way it looks there. You would still get the answers, and then readjust later. It's not a big deal. But I feel sometimes simplifying expressions makes life a lot easier. So what are we going to do? We say, how many times does x go to? Minus 2x. It goes minus 2 times. Then minus 2, we multiply the first term. So always know, guys, this is from grade 9. We did this in grade 9. And then grade 10 as well. With now quadratics and stuff. Grade 9 linear stuff. So you can't be weak here. Now, minus 2 times x is going to give us minus 2x. Minus 2 times plus 3 is going to give us minus 6. Remember, there's a flying around negative. Now we say minus 2x plus 2x is going to give us 0. And then we just write that dot there. And then we have here minus 3 plus 6. It gives us a plus 3. Now, there's nothing we can do here. So this is the remainder. So now what does this mean? We know that essentially we can say therefore minus 2x minus 3 is equal to, we take the quotient, we multiply the divisor, then we add the remainder, because those things are going to give us exactly what we want. Sorry, this is minus 2. So you can see, guys, if you redistribute this, it's going to be minus 2x minus 6 plus 3, which is going to be minus 3. It's going to give us that as it is. And if we take this further down, it goes back to that and that. So, of course, guys, I don't know. This looks a bit longish, but you need to understand how things are done. Now, what are we going to say? We can say, therefore, we can say then, f of x is literally equal to, instead of that, we're going to write minus 2 into x plus 3 all over x plus 3, because we're just trying to sort out the numerator. Now we say this implies that f of x is, now we split this. This is one term. It's going to be minus, okay, let's start with the positive one. It's going to be 3 over x plus 3 plus minus 2. I mean, we can leave the minus 2 in front. We just take the sign of that term in the numerator. So this is minus 2 into x plus 3, all divided by the denominator. This is x plus 3. But do you see magics? Yeah, man. There's a magic. So x plus 3 will be divided by that x plus 3 into 1. Now, 1 is a multiplicative identity. Wayibona biyano. Wankwa biyano. Wankwishisha mos. Ya, wena wankwa wena. Wankwa mos. Wakwishisha mos wankwa. Mgalabe. Manasesi. Agerikwa na manasesi. It's on. Anyway, guys, can you see this show? 2 marks? Really? Hi. And the anyway, guys, hi. Sometimes indaba zakwa-maths zakumangaza. Now let's have a look and see, guys. Where are the marks? Now this is a means to an end, right? Right. But is it not mark worthy at all? I don't know. So I will say writing that numerator into its factors, at least showing us how you got them. I think that's more important, and then splitting this fraction into these 2 fractions. That's good enough. And then the division of the factors into 1 and stuff, the answer was already given. As long as everything ties up nicely, well, 2 marks. But what about simplifying this? I feel this is not right. What about factorization? Because when we factor out the negative, the 3-step approach, every time we apply factorization, we should be scoring marks. So there are so many marks that I'm missing here. I'm not happy. You know, I'm really not happy. Because even getting this quotient right here, what about it? That's a mark, you know. But in any case, it's a means to an end. Okay, maybe we can accept. But you see, we lost literally 2 marks. Okay, maybe this step is not so big. But hey, guys, there's transformations I feel 3 marks. Okay, maybe this one is not the strongest, honestly speaking. Because when we actually multiply, we don't really get marks. But here, the factorization is the 3rd mark, which would fit that statement, okay? Masike sibe right ke ngoku siye ube sibhayiza nathi. Ndiyakunika ke mntana wesikolo la mark. Examiner yakho ibibhemile la. Ibibheme intsangu. Ukudla kwamahashe igijima nje mbumbumbu. Alright, masiyeke khonapho ningathethi into ezininzi ke bantwana besikolo nizandihlanyisa. Ningakulinge nje nifuna undihlanyisa. Antshongo mna lento endiyitshilo. It was a sneeze. It was itchy. Fabane. Siyavuma makhosi siyavuma. Alright guys, what is the other way? Now let me show you. The other way around. There are two ways I know. Now when I'm given f of x equals, but I feel it's better when I write it like that. So all the steps you're going to do until this particular step right here. Because if you don't simplify, remember denominators that are negative, we don't accept. We prefer the negative to be in front or to be on the numerator. That's the rule in math. So this is not nice to work with. So from there, we know that we're going to say, well, minus 2 into, now we just take this denominator and plug it for x. So we're going to write x plus 3 like that. Then we say divided by x plus 3. Now we ask ourselves, how are we going to obtain that minus 3 now? We first distribute. Minus 2x, minus 6. Now what do we need? We need a plus 3. Right? Logically, this is now from inspection. So this is what you do, because whatever you get here, you try to adjust it by another number so that eventually we end up with minus 3. As you would see, this is minus 6 plus 3, which is minus 3. So we will end up right there. So this is by inspection. I don't know how lucky you would be if you do this. But for me, inspection is still, remember, show did not specify how we're gonna do it. So by inspection, actually this is valid. This is valid. Writing, but again, you have to simplify until you get here, right? So you'll still get that mark. And then once we get here, well, we don't get a mark, but from here to here, we get a mark, okay? And then we split the solution. So we've got minus 2 into x plus 3 all over x plus 3 plus 3 over x plus 3. And the rest is history, guys. This leads up to f of x equaling, we can start with this. All right, when the magic's okay here. Nice and easy, guys. So that's an alternative approach, which is much simpler. So inspection still works even with fractions. So this is by inspection. As you can see, less work, but still the simplification, you cannot be spared. But long division, guys, there's nothing wrong with it. Please learn it and master it. All right, good. We move on. 3.1.2 says now hence determine the coordinates of the intercepts with the axis. So we can say for x intercept, it is such that, remember, y0 is equal to 3 over x plus 3, minus 2, which implies that 2 over 1, we transpose it, is equal to 3 over x plus 3. Now we cross multiply here. You don't need to show what I'm showing you. And then we come up with 2x plus 6 is equal to 3. Therefore, x is, transpose the 6, we get minus 3 divided by 2, it's minus 3 over 2. Now we can write, therefore, the x-intercept is given by minus 3 over 2 and 0. Question said coordinates. Ndicela uyihlohla la eka-y-intercept because you know what, ispace sam sizawudleka. Andinqweneli ukubhala kakhulu. Yeah. So we can say here for y-intercept, it is such that f of 0 is equal to 3 over 0 plus 3 minus 2. Therefore, f of 0 is equal to, this is 1 minus 2, which is minus 1. You can say, therefore, the y-intercept will be such that 0 is to minus 1. Now, these are very important to work out properly. Again, for me, the marks don't match the job, so I'm not happy, because first of all, to substitute a 0 here should be a mark, then to write the answer should be a mark. The coordinate pair is fine, but the mark was technically there. Or we can ignore the mark, but that was a means to an end, but this is the question being answered. But here again, substituting 0, okay, maybe we can say it's the same question, a substitution of the same number, even though it's in a different position. We can give you a mark here. Okay, it's fine, it matches. Thetha kakhulu nawe wedini, siqhela kabi. Bona go, uyabona go uyavela uba elawe salawula qodo kanjani. Sisiqhela kabi wena man, damn it. Sketch the graph of f. Clearly indicate the intercepts with both x's as well as the asymptotes. That one is a piece of cake. This is a piece of cake, this one. Ivele ikekele le nto. Sinihlanyisa wena. Okay, hayi, noba ikekele ayisenandaba, izawundigulisa. Anyway, okay, masenze kanje. Now let's see. X, y, origin. Now, we know that the asymptote from the graph is minus 3 here, the horizontal. So let's do it. Not the horizontal, but the vertical asymptote is there. So asymptote must be broken lines. Okay, so this is at minus 3. Now, the horizontal asymptote is minus 2. Like that one. So, if we say this is 1, then that should be 2 right there. Of course, guys, I'm doing approximations now, so that I can get a nice graph. Otherwise, there's nothing too much here. So this is minus 2 right there. Now we can clearly see that we need to extend these values so that our graph looks nice. Yeah. Technology, baba. Technology. Ayisuka nawe man. Usuka nini ngokutyini abafondini? Yandihlanyela nje. Ingihlahlela amehlo manje, yangibhayizela. Now we know halfway here should be 1.5, which is minus 3 over 2. And then halfway here we know that there should be minus 1. Alright, so what this graph looks like, it approaches the asymptote, cuts, and does its own thing. And the other portion to it must be similar to that. Okay, it doesn't look too nice, but yeah, whatever. doesn't look too nice, but usually you will see and appreciate that the other graph, remember this one is coming from left to right, it's better to put the arrow down here. Unanimous, yeah, and up there. Hell yeah. So that's -1. That's -3/2. And everything is as we expect. So we just label our graph that this is f. So we've shown our asymptotes. It's nicer when the coordinates are shown on the axis. Because kwezinye indawo izandihlanyisa ivele ibe mdaka igraph yakho, and yet it should be a neat sketch. There's a word that is missing here. Draw a neat sketch, not a busy sketch there. Anyway, let's have a look. It says now determine the equation of the axis of symmetry with a decreasing, which is a decreasing function. So the axis of symmetry, we know that it should be passing right here somewhere with a gradient of -1. Now this one is not part of the question, so you need not show it, but I'm just showing you because almost you don't understand these things. Remember, this one passes through the intersection of the asymptotes. Now this is the line y is equal to -x plus c, literally. So this is what we are being asked, but this should not show up on the sketch. I'm just showing you, students. 3.1.4. We know that y is equal to -x minus p plus q. This is the best formula because it solves the pain. So whatever this x minus p is what is on the denominator of that fraction of the graph. And then q is, as we see it there, it's -2. So we can say therefore y is, we distribute, it get -x, -3, -2, it's -5. Nice and easy. Of course, guys, you can still use this format, then substitute the center, which is the point of intersection of the asymptotes, and you would see that this is -3 is to -2. So we say -2 minus into -3, that's +3. You transpose, it's -2 -3, which is -5, equal to c, and this is what you end up with. So it's very easy. Now we have a situation here. Determine the value or values of x for which f is decreasing. So 3.1.5a, decreasing. Now we can see that f is essentially a decreasing function, because if we draw tangents along this graph, we can see these are all negative gradients. So we appreciate that when a is greater than 0, when a is greater than 0, the graph is literally a decreasing function. So it actually decreases everywhere except at the asymptote. So we can just write x is an element of all real numbers, but x cannot be equal to -3. Done. So that's a mark and the restriction. Nice and easy. B, f of x is greater than or equal to 0. Where is that? Well, if we look at this graph in this interval, we'll appreciate that here, this graph in that region, because we're saying greater than 0, so that means the graph must be positive, at the same time equal to, so 0 is included. So it's this interval from -3 to -1/3. So we can say here, well, x must be less than or equal to -1/3, not 1/3, but 1,5, but it should be greater than -3. Why are we not including this? Because it's an asymptote. Great stuff. Sure, usually for the inequalities here we get a mark, and for the values, but usually I just see the notation getting 2 marks. It's more like a standard. Alright guys, so this was that. Now let's get to the parabola. So 3.2. Sketched below is the parabola f and the straight line g of x. Okay, now what is that? The y-intercept is 6. We work out the x-intercept. Minus 6 divided by 3. It's going to be minus 2. And we are told that r and s are the x-intercepts of f. Okay, you see that. And g has its x-intercept at r, so we saw it. I mean, the sketch was saying it already. Then p with minus a half and 9 is the turning point. The turning point, if that is the turning point, that means the axis of symmetry here is right there. Right? Right. So that's the axis of symmetry here of the parabola. So it means it's at minus a half. Now we know that this distance from this x-intercept to this axis of symmetry and from the axis of symmetry to the next should be the same. So minus a half minus minus 2. Right? It's going to be 1,5, isn't it? It's going to be 1,5. And we know that here we need to add 1,5. So this distance is 1,5 units. So this one should also be 1,5. So this is more like moving this point 1,5 units ahead. This lands us exactly at 1. So we can work out the coordinates at each point using the information provided. Now what we wouldn't know is the y-intercept here. That would have to work out, but most of the points we can. And here, once we have the full equation of the parabola, we can use points of intersections. It will still reveal this as well as that point again, which is good, but we can see there's no question about it. So calculate the coordinates of r. Very easy. 3.2.1. We know that r is such that essentially this is where g is 0. So 0 is equal to 3, or maybe let's write nicely here, is such that g of x is equal to 0. Why do we know this? This is an x-intercept of g. So this implies that 3x plus 6 is equal to 0. Therefore, x is equal to minus 2. We can say, therefore, r is the point minus 2 and 0. Please, guys, do the notation right. Don't write your own notations here. Some things you can be flexible about, some things you can't, because they mess up with the general notation. So issues of notations, they are no, there's not much flexibility if you're not going to confuse us at the end. We don't want things that are going to lead to issues and controversies. So that's easy, guys. So this one, yeah, and the coordinate pair, because the question said coordinate, not x coordinate. Be careful. The ordered pair is critical there. Now determine the equation of the parabola. Very easy now, because we now have the coordinates of r as minus 2 and 0. That's the point on the parabola. So we can use that point. So we know that f of x is a into x minus p. Now minus a half is going to be plus a half, all squared, plus 9. This is the turning point format. Now we substitute a point r, which is minus 2 and 0. We know that 0 is a into minus 2 plus a half, all squared, plus 9. So this implies, now we're solving for a. Now what is this? This is going to be 2 there, that's minus 4 plus 1, that's minus 3 over 2. Minus 3 over 2 all squared is basically 9 over 4. A equals, we transpose the 9. It's like that. Therefore, A is, now this will flip, so this is basically minus 4. Nice and easy. And again, A is negative, it's a grumpy face parabola. And we can see that if we were to draw tangents here, they are very steep. So the A value, the size of the number, spare the sign. The size of the number, the bigger it is, the very steep the gradients will be. Of course, the sign tells us about the shape of the graph. So there's a lot of things to look at and appreciate. Of course, can you see this sketch is representative of what is given rather than being a total mismatch. Anyway, we can say then f of x is minus 4 into x plus, a half, all squared plus 9. There's nothing that makes us do more. There's no need to do more. But you can, if you like. I mean, students are always students. They like to waste their time at times. So we know that this is going to be x squared times this is going to be minus 4x squared. Now we say this is going to be half of x times 2, that's going to be x, times this, so it's going to be what? Minus 4x. And then we know this is going to be a quarter, right? Because 1 over 2 squared is just a quarter. Times that, we get minus 1. So this could be exactly like this. Did I say that? Minus 1 plus 9, sorry. Minus 9, I forgot, plus. Now the constant will come up again. So it's going to be minus 1 plus 9. That's going to be plus 8. Now that makes sense that our our y-intercept here is 8. And you can see this is below 9. It's not that far from 9. So it would make sense. So the student can expand this and present the answer like that. As you can see, you can move quickly once you know what to do. Now what are the marks here? 4. Okay. Writing this in the turning point format is good. Substituting a point is good. Solving for the value of a is good. Rewriting in a recognized format. Whether it's this or that, it doesn't matter. Okay. It's easy, ne? Nice. 20 marks. All right, okay, all right. So let us bona le nto le nivele niphaphele andiyazi why mayenganiqheli kabi man tyhini nabafondini. Okay, let's get to question 5. There's too many questions here. Okay, question 4 is asking, nice and easy, the graph of the inverse. Now this means inverse of x is equal to the square root of 3x, where x must be greater than 0. Why? Because we can't have x as 0. Oh yes, we can, but we can't have x as negative. So it can take 0, yes, it's included, and more than, so that we take a square root of a positive for this to exist. So that's good. We understand the function of the restriction to make up for the invalid solutions there. It's drawn in the sketch below. Now the inverse passes through this point. Now if we inspect this point, you'll see the y value and the x value are the same. So what does that mean? This is where essentially this is the inverse line right there. That's the inverse line. What is the inverse line? Is the line y equals x. Why? Because x is equal to y. Oh, sesiyayibona ke ngoku. And Obviously. Izothini nale nto ngoku? Le nto lena ke ngoku izama ukusichazela uba wake batakwethu, the other graph is going to be doing stuff like so. Right. The other graph is going to be doing that stuff. So that should be F. Because zizawulingana phaya kulaa point. Ziphinde zilingane at the origin. So that is the story that is trying to give us. So again, guys, you need to be quick with these kinds of things. But hey, whatever, man. So 4.1.1. Determine the equation of F. Easy. We know that F of x is going to be such that. Now remember, 3 marks, we can't just write the answer only. Koda we can. This can accommodate because the determination is by any means necessary. Right. But now let's just do the standard way. We swap x for y. And then this implies that we square both sides to get rid of the radical. So this implies that x squared is going to be equal to 3y. Therefore, y is going to be equal to 1/4 of x squared. Therefore, f of x is 1/4 of x squared. But remember, this has both this arm and that arm. Now, for an inverse to be a function, it means we need to restrict this. And obviously, we can see that the inverse is restricted for the positive axis. Therefore, that should also be the same, because if we do that, then we are in a different situation. So we need to provide the restriction where x is greater than or equal to 0. Without the restriction on the original, the inverse cannot be a function. But we can see that this inverse is a function because it passes a vertical line test. So if it is a function, it means the original must have been restricted. So can you see it definitely did pass the vertical line test in that the inverse was intersected by just 1 point. So easy. Now what is the story here, guys? Well, do we get marks for the swapping of things? Maybe not, but we know that this is good. So definitely the swapping of stuff here looks good. The algebraic technique doesn't really matter. So that works out nicely. But the student who understands maths could just decide to write f of x is 1/4 of x squared and write the restriction x must be greater than or equal to 0. Alright, alright, because you can just do it by inspection. Nobody said show all the solutions. Remember, in this scenario, you get 2 marks for the answer, 1 mark for the restriction. So an answer only here is accommodated because it has got 2 components, the strong one and the next one. So that means an answer only can be given here provided the restrictions are given. Are we clear? Yes. So we may not see this, but yeah, it is like that. Let's go on. 4.1.1. 4.1.2 says, now for which values of x will f of x be less than or equal to f inverse of x? Now we can see these two are equal at the origin and at that point. So let's try to drop it down to the x-axis, and we will see that this is at 3. But now, what is this place that we're trying to look at? Is this space right here. Okay. So that is that space, isn't it? Because we see that in that interval, we can appreciate that the graph of f is below the graph of the inverse for the same x value. But at the origin, they are equal, and at that point, they are equal. Then everything switches up. So the interval that is correct for us is this one. So we can write here x must be less than or equal to 3, but greater than or equal to 0. Yes. Can you see drawing that sketch was very important? Otherwise, you would be burning. Yes, you would be seriously burning. Okay, guys, 4.2 is a different question altogether. Can I answer this here? I'm not so sure. Let's try. So we have 4.2. And then we are given this graph, and then we need to determine the inverse. So 4.2.1. We know the inverse is going to be y is equal to the log. The exponent becomes the number. The base is the base of the log. That one is not negotiable. 2 marks for the answer. Right. If you don't know this, well, go cry. Then come back and face reality. This now says we need to draw the graph of the inverse of g, indicating any intercept with the axis, as well as one more point on the graph. Okay, that's not a difficult question. This we can do with our eyes closed. Okay, so we've got x, y, the origin. So we know the logarithmic graph. If this base is like this, it's a decreasing function. Now we go on and say this is what it looks like. So this is g inverse. Okay. Now where will it cut? At 1, right? Then it has a horizontal asymptote, because this graph itself, one needs to appreciate that this is the graph like this. This is a graph like this. It's a decreasing function which cuts at 1. Why is it decreasing? Because the base of the power is a fraction. But because the coefficient of this entire power is an invisible +1, so the graph appears above the horizontal asymptote, which is this. So if we draw these together, this is what we're going to end up seeing, with this one cutting at 1 as well. And if we're drawing these two in the same set of axes, we need to show this line, y equals x. You know, yes. So we need to show that inverse line when we are drawing these together. But when we are drawing this one alone, we don't need to show the inverse line. All right, okay, all right. So this is very easy, guys. So we know that this is g, and this would be g inverse. Nice and easy. So these things need to come naturally and as quickly as possible. So we were asked to find another point. So I want that point to be at exactly 1. So where can it be? If I say this is 1, right there. So I am going to be looking for this point. Now looking at my function, I know when the base is the same as the number, this is effectively 1. So this is when x is a third, and it goes to this point. So I can call this point A. That is one other point. So I don't need to write the coordinates. It becomes dead. I prefer to write them on the axis. So I've complied with the requirement. So we get a mark for the shape. We get a mark for this point and the x-intercept that we were asked. So there is our 3 marks. Nice and easy. So we have 4.2.2. This one says, well, not 2 but 3. This one says the graph of h of x is like that and it passes through this point. So calculate the value of a. So we know that, well, h of x is a into 1 over 3 to the exponent x plus 7. So through this point, whatever it is, minus 2 is to 10. It will be such that 10 is equal to a into a third to the exponent x plus 7. Now this implies I want this one to give me a. So okay, I'm supposed to substitute here minus 2. Now essentially, guys, what am I getting here? I'm getting a into 3. I can change to the negative exponent so that I can eliminate that. Okay, I don't like to write like this. So this implies that I've got a into 3 to the minus 1 to the minus 2. It's still doing it. Stupid thing. Now I'm going to transpose that to that side. I'm going to get 3. Right, I'm just rearranging everything. So I know now that therefore a is going to be a third. How do I know? This would be 3 squared. Now 3 divided by 3 squared is just 1 over 3. Now that's it. That's it. Okay, how many marks there? 2 marks. Yep. Substitutions and answer. Not too complicated. So 4.2.4. Question says, describe the translation from h to g. Now can you see h of x? Let's start here. H of x is equal to a third into a third to the exponent x plus 7. Now look at g. G is the way it looks, but now we need to first sort this up. When we multiply same powers with the same bases, remember this is a third to the exponent 1, right? But now we don't need to do that. We should just appreciate it. Now, therefore, it means our h of x is, we write this with the same base, then the exponents will add. Now, this is the standard format of writing this. Nice. Now we can see that, okay, since g of x is just a third to the exponent x, what happened? It means here we subtracted 1, right? Yes. And then here we subtracted 7. So now these are the actions that inform what happened. Of course, guys, we're not going to write these things here. This is just me trying to explain to you that how did we move from here to there? It means we subtracted 1 so that the 1's cancelled, then the 7's cancelled. Now this is what answers the question, the actions that we did. We can say therefore G is H. Now this is a translation, translated horizontally by 1 unit to the right, right? because when the negative is like that, we're moving it to the right, and 2, and 7 units downwards. Now that's a translation. It's a push, it's a shift, it's a shove. I wish the examiner just said transformation. Right, so that one can decide, is this a translation versus a reflection? Okay, need to trick the students a bit, guys. Even though it's term 1, we cannot be gifting marks to these guys. They can't go on to get distinctions at the end of the year with poor knowledge. Policeman. Let's not have this. Now, writing this in standard format, excluding what I just, highlighted, that's a mark. First, describing the horizontal translation to the right by 1 unit, that's a mark. Then the vertical and units vertically downwards. Maybe let's put it down that this is a vertical shift, vertically downwards, vertically or vertically. Is it vertically or is it vertically? My writing, vertically down or vertically downwards. Okay, downwards is okay. Maybe let's say vertically down. I think that's perfect. Yeah, please listen to what you say, folks, because it's a horizontal to the right, that's a mark. 7 units vertically down, that's the second mark. Okay, total of 3 marks, and we can appreciate that this 15 marks was the easiest we have come to, except perhaps for this question here. This is a higher order question, and expect it in your friendly examination that may allow you to enter some university scot-free, or maybe you might just enter but with some things for you to fulfill. Otherwise you get kicked out of the program you chose. Anyway, guys, so far so good. So of course a student would be told it's over, but again, it's because I'm taking some liberty to explain. So let's rush through this question 5. Now this one is easy. 5.1. We are given what we are given. Okay, maybe let's start. 5.1. We have sine beta is equal minus 4 is equal to 0. So 5 sine beta. Now this implies that sine beta is going to be equal to 4 over 5. So we must write this in standard format, and we need to choose the quadrant that answers this question. Which one is it? We can see that beta is an element of 90 to 270. So this is positive. So sine is positive in the second quadrant. Therefore, so our terminal arm is in the second quadrant. Okay, I'm yes, it's this thing. Keep an eye resistance if I'm So remember, this is a construction of some sort. All we have is the terminal arm. Now we need to show the angle. It's an obtuse angle. So this is our beta there. Okay. Now that the sketch is complete, how do we define sine is opposite of a hypotenuse? So you should know that this is going to be essentially minus 3. But you don't need to just write the number. We need to see how it's done. We know that essentially x squared plus y squared is equal to r squared. We know this from utatu Pythagoras. Utatu Pythagoras nguye otsho izinto esithi. Accuse. Don't accuse us. We didn't say it. It's Tatu Pythagoras. Nguye lo otsho izinto. X squared is, this is 25 minus 16, which is 9. Therefore, x here is minus 3. Strategically. Why? Because we understand that this is the negative x-axis, so it has to be minus 3. So on the Cartesian plane, we need to stay true to the Cartesian plane. We can say now 5.1.1. We want cos beta, which is going to be adjacent, which is minus 3 over 5. Nice and easy. So this one is 3 marks, but it's just 1 mark here. Where's the other mark? Where's the other mark? Because we were told nicely not to use a calculator. So if you show any signs that a calculator was used, you are dead meat. Even though you may use it here, but we need all the steps. Yeah boy, yes. Okay, so 5.1.2. We now need cos 2 beta. Now we know sine, we know cos, so we can just use this one, cos squared beta minus sine squared beta. This is much easier, which is going to be equal to cos is going to be minus 3 over 5 all squared minus 4 over 5 all squared. Now you cannot just jump to the answer. That means you used a calculator. You go down by the head. So we need to expand the brackets nicely. You jump, you die, because it will break your legs. Again, we need to see that you used arithmetic rules, finding the common denominator. So we get up 9 minus 16. There has to be a show, guys. We can't just show up with the answer. It means the calculator was used. Now 9 minus 16 is minus 7 over 25. Nice and easy. So of course you can check if your answers are proper with the calculator now that you have done it, you know. Be very, very careful, guys. These things look too easy, but these are marks a student loses. So this confirms no chicanery, no manga business, because we need to stay on our game. Now, using identities as part of the 3-step approach, substitutions, and the final answer. But these steps are as good as ever. If these steps are not shown, it means a calculator was used, so you lose the last mark. Be very careful. Now I can tell you guys, from this kind of question, it is asked in 3 ways. First, it's a direct question like this, but it has to come from some workings, right? Either the direct angle here or the complement. And then we will have identities that involve either double angles, square identity, tan identity, or the compound angle identities. Now here we have a double angle identity. Now let's go on. We have 5.1.3. We need to sort out sine 3 beta. Can you see this is a compound angle identity? First we set it up nicely, then we do the expansion, sine first angle, cos second angle, the sign remains, cos first angle, sine second angle. Now this is yet another identity, so this is 2 sine beta times cos. Now cos beta is going to be cos squared beta, plus, we leave this one because we know cos 2 beta from above, times sine beta. Nice and easy, so we go on. We have 2 into sine beta is 4 over 5. Then cos squared beta, we know that that was minus 7 over 25. Right. Ayisoxoka wena man. Ufuna ukunithengisa, mthengisa indini. Sokundibhayisa wena. So this is minus 3 over 5, but now squared, plus cos 2 beta, from above we got minus 7 over 25, times sine beta, this is 4 over 5. Easy, ne? It's easy. Now let's get it done, guys. So this, like that, is going to be 8 over 5 into 9 over 25. Now this is going to change to negative 28 over 125. Step by step, guys. But now I feel like you. Ixesha lam liyadleka. Andifuna ukuphumela ke ta. Kodwa ngathi andina choice. Yes. Masivele siyidilize. Ngoba sendiqhubela kwi-situation endingayithandi. Okay, so let's go on here. 8 by 9, that's 72, divided by 125 minus 28 over 125. Nice and easy. Common denominator, 125, so this is 72 minus 28. So the answer is 72 minus 28, so 12 minus 8 is 4. Then 6 minus 2 is 4, so that's 44 divided by 125. Here you can cheat. Because I back. But we're not going to show the long whatever. You see, you can't jump. Even if it's just for 4 marks, guys, you cannot jump. First of all, we used identities. Good. And then we used an identity here and sorted it out quickly. That's a mark, and then the substitutions, that's a mark, the final answer. But these steps need to show. If they don't show, we know you cheated. Okay, thank you, comrades. So let's do 5.2 here. Now 5.2, we are simplifying sine of minus 180 degrees minus theta times 10 180 degrees minus theta times cos of minus theta, all divided by cos squared 90 degrees plus theta plus 3 sine squared theta. Okay, easy. We know the 3-step approach. So guys, let's look at the Cartesian plane. It's like so. So we know that this is minus 180 degrees or 180. So minus 180 minus theta takes us to the second quadrant. So this is where our angle is. So sine in the second quadrant is positive. So this is sine theta into 10 of 180 minus theta. So again, 10 in the second quadrant is negative. Then cos of a negative angle is just cos theta. All this divided by, now this is going to be, essentially the co-ratio here is going to be sine, but cos is negative in the second quadrant, so this is like this all squared, plus 3 sine squared theta. Now we move on. How? 98 10. Now we deal with the stuff nicely. So this is sine theta multiplied by, now this is going to be minus sine theta. We use the 10 identity over cos theta times cos theta over 1. So this is over 1. Now all of this is divided by, technically this needs to come here. And then we deal with this. This is going to be just sine squared theta plus 3 sine squared theta as we sort it out. Now magics happen. This divides to 1. The numerators multiply. So we get minus sine squared theta divided by 4 sine squared theta. Now magics happen again. So we only get a quarter, negative a quarter. Okay. Now the three-step approach, you can appreciate I'm rushing through it nicely. But now how do you then prove this? You take this. But you need to be very careful now of how you're going to do this. You just say theta, you just choose any angle, 2 degrees. That means you just plug that on the calculator. Let's go for it. I've got sine of minus 180, then minus 2 degrees. Okay, that into, now be very careful of brackets, 10 of 180 minus 2 degrees. Now be very careful here in terms of brackets. This into cos of minus 2 degrees. Again, be very careful of brackets. Divided by, we're going to write here. Now, essentially here, what we want to do now is to square this situation. So we're just going to say into brackets cos of 90 plus 2, right? But now we need to square that. Be very careful with your brackets here. And then plus, then we're going to say 3 into the sine of 2 degrees. Again, be careful there to make sure the brackets are used properly, and the square. Now what answer do I get? It's negative a quarter. So what I get here is negative a quarter. So this proves my reduction is proper. Okay, learn the tricks, guys. Make sure you don't go with unchecked work when there is a chance to check it, so that you can score maximum marks. So how do we score marks? First of all the reductions, 1, 2, 3, 4. Okay, those are the 4 marks. And then using the 10 identity, whenever we use an identity, we get a mark, and for the final answer. Okay, remember the squaring here is not a big deal. What matters is the reduction. Okay, nice and easy. So we have how many marks now? 1, 2, 3, 4, 5, 6. Yes, 6 marks in the bag. Okay, so let's do 5.3. Now 5.3, we need to prove the identity. Still 3-step approach. We go 1 over 8 into 1 minus cos 4x is equal to sine squared x times cos squared x. Okay, we can see we always choose the complicated side. First of all, brackets is a complexity. The angle is also a complexity. While the angles are singletons here and just simple squares, a simple product, one term, too many terms. So that qualifies. So we can say left hand side is 1/8. Okay, what I'm gonna do now, I'm gonna just put a big bracket here, that this is 1 minus cos of 2 into 2x. I'm gonna make that a double angle. Right. Nice and easy. Okay, maybe I should not rush. Let's just show you guys a stepwise approach properly without rushing anything. So this is cos 4x. We first write what we are. So this is equal to 1/8. Yo, ayibo, khawubhale kahle ndoda. Kanti kuvele kuthini? 1 minus cos of 2 into 2x. I'm choosing to use the double angles here rather than the compound angles. They irritate me because they become too big. This is good like this. So this is 1/8 into 1 minus. Now we can expand this. This is going to be cos squared 2x minus sine squared 2x. Right. 1/8 into, we break this up. In fact, once we do that, we know that technically 1 is sine squared 2x plus cos squared 2x. This is an identity as long as the angle is the same, guys. I'm using 2x because I want to eliminate here. So this, when we distribute, is going to be minus cos squared 2x plus sine squared 2x. Okay, that's nothing. Now magic happens. Okay, we get 1/8. Now we can make the bracket round. So we're going to have 2 sine 2x. So it's 2 sine squared 2x. Okay. Now we can use our identities here. Okay, maybe we rushed. This is still not done. Let's keep it. Now this is 1/8. Can you see it's a lot, guys? Some expressions can be annoying. So we've got 2 here into, expand this thing. This is going to be 2 sine x cos x using the identity, but it's squared. Okay, be careful. This is very easy after all. So let's first deal with the square here. Right. So we have 2 into, now this is going to be 4 sine squared x cos squared x using exponential rules. And then we deal with the bracket. It's 1/8 into, this is going to be 8 sine squared x cos squared x. Distribute the 8, so we just get sine squared x cos squared x, which is equal to the right hand side. Identity proven. And you see, it looks simple. It's just 5 marks, but can you see? It's a long, lengthy thing. Anyway, it's just the approach, guys. You can choose whichever approach you like and run with it, okay? Now, all of this setting up business is not important, but when we use an identity, we get a mark. When we use an identity, the square identity, we get a mark. The simplification is not too big, but when we use an identity, that's a mark. The distribution doesn't really matter at all. So obviously now this says 3 marks, but we're getting 5 marks. Okay, this multiplied here perhaps should be a mark. It looks valid. This squaring and multiplying, it sounds right to me. 1, 2, 3, 4, 5. Okay, so at the end of the day we have our 5 marks. And of course, guys, this is to a total of 21 marks. And that marks the end of our revision, because we have done this one in the channel alone. So look for that video and enjoy the whole thing. So that's it, guys. I hope you've enjoyed the video. You can give it a thumbs up, or even consider subscribing for more. And some of you are already students who are doing classes with me. So guys, we're going to resume our classes on Monday, 7 o'clock at night, as usual. And then we'll be trying to push term 2 work. But for those who are doing the upgrades, I think we need to fortify paper 2 material doing as many questions on Euclidean geometry and analytical geometry, because I think we have dealt with trigonometry properly. If there's any gaps, we can still revise, but I don't think it should be the problem if you did work as I have outlined it for you guys. So I've taught you everything on trig, starting you from the beginning to the end, the complex end. And we've also done a lot of questions now to highlight how things are done there. Should be easy. Now we're going to need to drill Euclidean geometry, especially the higher order questions, because the rest of Euclidean is usually very easy. And analytical geometry, usually the question 4 is a bit technical, and maybe the last questions on question 3. But again, it's just a matter of, do you remember what you did in the previous grades? Can you integrate it into grade 12? Otherwise, it's fairly easy. It's a grade 11 type of question in the most of the analytical geometry. It's purely grade 11 with some spices of grade 12. Maybe the circle one is purely grade 12, but some grade 11 questions get asked. Then stats, guys. I swear. Do I really need to teach you that? I don't know, but I don't think so. You really don't need that thing, but I can show you. Because you know what, guys, there are some simple things there that often cause trouble. But I would rather you just watch videos on my channel for the stats part. Should be easy. But I think what we need to focus on for paper 1, term 2 is financial maths and probabilities. Because calculus and the cubic graph, guys, are very straightforward. Usually, what you do in the classroom, classwork, class tests, homework, is pretty much what you get in the exam. Maybe with some smaller areas, but usually there's no difficulties with the cubic graph, with calculus, differentiations. I mean, it's a matter of just knowing how to simplify algebraic expressions using the 3-step approach. But I think probabilities, we need to build up some knowledge, because I technically don't understand that section myself. But I have realized that most of the time I attempt questions doing these reviews, I actually succeed. Because at the end of the day, guys, logic and mathematical knowledge will never change. If you apply it well, you are going to survive anything. Even if you barely do survive, but you will survive. Okay? So, yeah, I think we need to sit on financial math. Just try to build it up from the beginning until, the complex end. And then we do, what is this called? Probabilities. Maybe the calculus part that may be challenging is the applications of calculus in optimizations and whatever. Maybe this is where it gets hot. Maybe we might just look at some questions that are probably technical in that regard. But the rest of the calculus, the differential calculus, is easy. Then, guys, you can go and write your major exams like stars in the sky. In fact, not just the small ones. Nibe low quiz, yabona quiz, the big star, the morning star. Ube mphatlalatsane man, naledi ya misa. Re bone ka wena hore boseo bo sile jwale. Wa ibona ntwena. Yeah man, leave us happy and become happy too. But remember, matric is just a stepping stone. And a very important one. You score high on matric, you don't have to work that hard at varsity. Because what is the use of a cum laude? I don't see it. Most of the cum laude people are not really that useful, actually. Okay, let's not say that. Hey, some people are going to be offended because, hey, they graduated cum laude. Just because I did not graduate cum laude. Now I'm better. You know, that's what you think. Anyway, guys, depends. You know, university distinctions are ridiculous, if you ask me. If you're not favored by those people who award you that distinction, no matter how good you are, they're not going to give you. Okay? Now, it depends again on whether you're truly good or you think you are good, because there's that possibility of overly projecting oneself onto some things. But I've seen it. I kind of believed I was good enough, for one, because of the results I produced, not just for me, but my fellow students, because I used to teach them and they would pass when they were barely making it. So I could not have been that inferior, okay, to just get, the Madota score. But hey, guys, you have to kick there's a girl which I like. She's in my university, but it was then called whatever it was called. Now it's SMU. She just posted on her TikTok some very interesting stuff that at university you need to kiss ass. Unfortunately, it is true. If you want a cum laude, you need to kiss ass, because you're not gonna get a cum laude if you don't kiss ass. That's just a reality, okay? Which tells you clearly that you need to be a favorite, and to be a favorite, you need to kiss ass. You're not just gonna be a favorite. Your humility, your humbleness, your working ability. If you're avoidant, you are more like an introvert like myself. You're not getting that cum laude. You're not gonna pass with distinction. Okay, no matter how well you do your things, your case studies, you pass your exams. For some reason, I don't know how they mark those exams. It's just crazy, man. Yeah, anyway, let's not go there, guys. You're gonna find out when you get to university that that place is just different from matric, okay? Yeah, part of the reasons people drop from distinctions to just, making it, if at all making it, it's not because it's too hard. There's a lot in it than just you sitting for an exam using your knowledge and stuff. It's just another place. But again, what I like about it all, though, despite, the cries we can create, it makes you grow. You realize, folks, that your knowledge is not good enough. You need to work with people. At some point, you need to accept certain things from other people and neglect certain things about you. Because if it's all about you, you're not going to succeed. So in the real world, unfortunately, as much as we can cry about what I just said, but it actually builds you up. It creates more humbleness in you. Because you start to realize that your knowledge gets shamed most of the time by the marks. However wrong that should be or it looks to be. But those shameful moments, if they are regarded as such, because obviously people want to brag that they are top achievers and stuff, they have awards and whatever. But at the end of the day, it creates a humble individual in you. And someone who minds their steps, because now you're no longer going to be an individual who makes mistakes and it's okay. You are becoming a professional. If you're a surgeon, you're a doctor, a wrong prescription, neglecting a blood result that, if you correct it, could actually stop the death, you will lose lives. So your mistakes, as much as they can be accepted to some extent, I'm going to say it that way, your mistakes can be accepted to some extent. But in the greatest of all extents, it's technically punishable. Because if you do that in private, you will be suffering litigation. You will go hungry paying insurance and stuff. But if you work in the public service, which is unfortunately the case for most of these negligent individuals, the state kind of covers the doctors because the heads of departments fail to control their staff members, because those are the people directly linked with the people who make all these crazy things. But again, this again goes back to saying, folks, are we really as good as we say we are? Or are we just average? And perhaps average is acceptable because it means you are safe. But if we are substandard, which is usually the case, but hidden by the marks which people just give to you when you actually don't deserve, then that's more dangerous, because you're hiding the fact that there's weaknesses in this individual, and you don't let that individual face their own music first. Become humble intentionally by seeing the outcomes they bring about. Then they can start to shape up and then live up to the level that they should be at eventually. And then we say that is the best because of the results, not because of the statements that can be made by whoever favors you, or some results that can be cooked to look good for you, depending on what you gave to get what you get, or depending on how you have been to get what you get, irrespective of, the normal ways of getting what we should get. Anyway, guys, this is politics right now. Don't listen to me when it comes to this too much. Take this with a pinch of salt, because guess what? I'm just a human being who has his own flaws. Too much logoria sometimes is just like diarrhea. You get it? Okay. Or polyuria of diabetes. You get it? Yeah. Or some diabetes insipidus. Yes. Anyway, guys, I hope you enjoyed the video. Please leave a thumbs up. Just, the little you can give me is a thumbs up, so that my video at least, relatively trends. Maybe I feel good when I see that, but I don't really care actually. But what I care about is other students being reached, or at least some tutors being reached, some teachers being reached. Because these reviews, guys, they may look too arbitrary. I'm not a teacher by profession. I don't know how to teach, from some proper training on how to teach. I just understand, certain things about teaching, because I have been a recipient of some teachings. So as a result, I saw that indeed there's something I can share with others. Although sometimes I can be a little obnoxious, a little difficult to put up with, a little tedious to keep up with. But at the end of the day, guys, if some student makes it because of what I do, even if it's just one, it's a mission accomplished. It's not about the entire world, because I know the entire world often resists change, especially good change. They often rubbish good things for bad propaganda. So at the end of the day, if you're not mullah, you ain't gonna be liked by everybody. No matter how good you can be, no matter how humble you can be, no matter how nice you can be, hey, they're not gonna like you. But there are certain, things that we notice that people just automatically, if not, as a given, they just like you. Even when you're hurting them, they just don't see it. Even when the damage is clear, they will still assign this to some sabotage of some kind. You know how ridiculous human beings can be. Hey guys, I have done my review nicely, I hope, and correctly perhaps, but please do verify some of the answers I presented by checking them against the memo. But be very careful though, the memo might be very wrong, I may be very right. So when you see me contradict the memo, be very, 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 very critical of me and the memo. Don't take one as a given over the other. I could be wrong, the memo could be right. I could be right, the memo could be wrong. This is where you need to sit at it and think about it. Look at other ways you can look at it and see which one becomes the consistent answer. And if you're not sure, you can ask me a question to elaborate my standpoint, or take a tutor or another tutor than me. I'm not a tutor, by the way, but look for a tutor perhaps than me, and then ask them and see what they can do. Go to your teacher, see what they can do. Go to your friends, see what they can do. And at the end of the day, not many can be right, and one is different, and that one is different. Quadratic reality is another issue, guys. You know, grade 8, standard 6, 2001. Must then go some standard 5. So early in the year, go 2001. And I was taught by the tsotzis of maths, guys. That's why ndiyitsotsa kanje maths. Nobani ngathi ngizohlala ndiyitsotsile. Ngoba ndafundiswa zitsotsi. Ingqonyela the mathematics teachers. Now, Ntate Mpomani here, that was our teacher before he left. He left, in fact, before our junior exams. He was gone to another school. He got a principal post. He was just a maths teacher at our school, a maths and science teacher. Man, the best, by the way. I wonder, where is that man? I would like to shake his hand at some point. As I have my elementary teacher, Umempotlo, and again, she went on to teach me standard 3 and 4, which was 1998 and 99. If I wasn't taught by that lady in those grades, maths especially, Mpomani would have found a very poor student in standard 5 and 6. And the rest would not have seen the greatest potential. Those people, as much as I was perhaps gifted, I guess, because I saw things, man. I could solve problems from the next class while in the other class, not having seen them, but just using the basics I've been taught. So I was that kind of a student, man, who could take the extra mile, effortlessly even. Anyway, guys, let me not praise myself too much, but what happened that year, 2001? We were given a very complex algebraic expression, in fact, arithmetic expression, because that one was just pure arithmetic, but involving fractions, brackets, you name them, exponents. Now the teacher said, solutions. Now she kind of volunteered the different solutions he got, Mr. Mpomani. He got from his best, Umzwa Tugela, and I mean, that was the beast, was standard 6. So now the guy was saying his answer, and everyone, because they knew him, they went with him, and many others were in between. Guess what? I was all alone in my corner, because our teacher said those were saying this there, those were saying. I sat there all alone. I mean, it's funny though that my standard 5 people who knew me from standard 5, that I was unchallenged when it comes to that subject. They didn't believe me, but I was the guy they were exposed to all the time. For all of us, people who just go with the wind and forget where they come from. Goodness, I couldn't believe them. Hey, Bayomali, Nomzwa Tugela, and others. Baba in your group, Jenga Yaimeno, some Kelisiwa, another girl was quite good. Okay, not quite good, but very good. Demand water, and guess what? I was right. And everybody was wrong. You get it? So all it's trying to say, guys, sometimes the crowds follow an absolute wrong path together like sheep. But I'm a goat. A goat can go it alone. Believe me, it can. It does. With a strategy. A goat, when it sees a field of mealies, when it sees it and it looks at you, it knows you are the umalus. You are the header. It looks at you. It goat ipoke bali padleka. Izakujomba ukude kangakanani. Ayiqonda ba hayi sasibhanqa sikude. Izawubaleka xa iqonda uba intsimi ingathi kufutshane ukude iyama laa nto ikujonge iphinde ijonge entsimini iqonda uba intsimi iseduze laa bhari kude le izawuthi ifika ndizabe sendilume noba kabini noba kathathu. It will speed up into the field, take its bites as often as it can, and as it does it ingena nzulu ukwenzela uba nangela xesha usiza uzoyinqanda izawuhamba iluma njengoba iphuma ayivele iphume. Bawkho is a smart one, you know, so it calculates. So unfortunately ndandiyibhokhwe ezigusheni. Anyway guys, bye bye, ndibona next time if there is such a thing, because you know what, I could be dead tomorrow. I'm sorry for just that word, but guys, life is just so unpredictable. We see a lot of friends and family going when we least expect it, when we think we have a chance, but we actually don't. So hey, we need to be cognizant that the best time is now, because we don't know if tomorrow exists for us, some of us. Anyway guys, goodbye. I will see you when I see you. Those of you who attend my classes on Monday, we are back on 7 o'clock sharp.